Alongside all these physical properties of water, its chemical properties are also extraordinarily ideal for life. Foremost among these properties is that it is an excellent solvent. Nearly all chemical substances are soluble in water. The most important effect of this on life can be seen in rivers. Countless beneficial minerals and similar chemicals are carried to the sea by means of rivers. In this way, some 5 billion tons of chemical substances are carried to the sea every year. These substances are essential for life in the oceans. Another chemical property of water is that its chemical reactivity is at the ideal level. Water is neither an excessively reactive and thus destructive chemical like sulfuric acid, nor an inert substance like argon that enters into no reactions at all. The compatibility of water's chemical properties with life emerges in even more detail with every new piece of research. Harold Morowitz, the well-known professor of biophysics at Yale University, makes the following comment. The past few years have witnessed the developing study of a newly understood property of water, that is, proton conductance, that appears to be almost unique to that substance, is a key element in biological energy transfer, and was almost certainly of importance to the origin of life. The more we learn, the more impressed some of us become with nature's fitness in a very precise sense. It is clear how important water is for human life. In fact, in many verses of the Quran, God has drawn attention to the fact that water has been given to man as a great blessing and has been made constant on the earth. We sent down a measured amount of water from heaven and lodged it firmly in the earth, and we are well able to remove it. By means of it we produce gardens of dates and grapes for you, in which there are many fruits for you and from which you eat. He who created the heavens and the earth, and sends down water for you from the sky by which we make luxuriant gardens grow, you could never make their trees grow. Is there another deity besides God? No, indeed, but they are people who equate others with Him. He who made the earth a stable dwelling place, and appointed rivers flowing through its midst, and placed firmly embedded mountains on it, and set a barrier between the two seas. Is there another deity besides God? No, indeed, but most of them do not know it. Whenever liquid is mentioned, one immediately thinks of a very fluid substance. Whereas the fact is that the viscosity levels of liquids differ greatly. For instance, The viscosities of tar, glycerine, olive oil, and sulfuric acid are all very different. Enormous differences emerge when these liquids are compared. That is because water is 10 billion times more fluid than tar, 1,000 times more than glycerine, 100 times more than olive oil, and 25 times more than sulfuric acid. So what is the importance of water's low level of viscosity for us? If this vital liquid were a little more or less viscous, would it make a great difference to us? Professor of Microbiology Michael Denton supplies the answer. If the viscosity was higher, the controlled movement of large macromolecules and particularly structures such as mitochondria and small organelles would be impossible, as would processes like cell division. All the vital activities of the cell would be effectively frozen, and cellular life of any sort remotely resembling that with which we are familiar would be impossible. The development of higher organisms, which is critically dependent on the ability of cells to move and crawl around during embryogenesis, would certainly be impossible if the viscosity of water was even slightly greater than it is. Water's low viscosity is essential not only for cellular motion, but also for the circulatory system. There are a large number of cells in the body, and the air and energy taken in from outside need to be pumped to the cells by a number of tubes, and waste products need to be collected by others. These tubes are the vessels of the circulatory system. The heart is the pump responsible for circulation within those vessels. The substance that flows in them is the liquid we know as blood, the fundamental component of which is water. The duty of the vessels is to carry essential substances such as oxygen, energy, nutrition, and hormones to every cell in the body. The total length of the average 5 billion capillary vessels in our bodies is some 950 kilometers. In some mammals, there may be as many as 3,000 open capillaries in just 1 square millimeter of muscle tissue. It is thanks to the low viscosity of water that blood is able to circulate in our vessels without becoming congested or slowing down. Michael Denton explains that if water's viscosity were just a bit more than what it is, the blood circulatory system would be completely useless. A capillary system will work only if the fluid being pumped through its constituent tubes has a very low viscosity. A low viscosity is essential because flow is inversely proportional to the viscosity. From this, it is easy to see that if the viscosity of water had a value only a few times greater than it is, pumping blood through a capillary bed would require enormous pressure, and almost any sort of circulatory system would be unworkable. If the viscosity of water had been slightly greater, and the smallest functional capillaries had been 10 microns in diameter instead of 3, then the capillaries would have to occupy virtually all of the muscle tissue to provide